Okay, now previously we calculated the acceleration as net force divided by mass and got negative 0.025 meters per second squared, meaning 2.5 meters per second squared in the counterclockwise direction. Now we want to take another look at the free body diagrams for the two masses, the 10 kilogram mass and the 10.05 kilogram mass. We've already looked at those previously. Let's take another look. Okay, so again, for the 10 kilogram mass, we have the tension upward, the gravitational force downward. Now, gravitational force is 98 newtons here. It's about 98.5 newtons here. The acceleration in each case has a magnitude of 2.025 meters per second squared. So we can calculate the net force in each case. The net force on the 10 kilogram mass is in the upward direction, 0.25 kilograms in the upward direction. Now, before we had downward as the positive direction, so we could say that's negative 0.25 newtons, keeping in mind downward is positive, but knowing it's 0.25 newtons upward is sufficient to draw our picture. And actually we're being a little inconsistent here, so let's get the signs straight. Well, having changed the signs, I realize we don't want to change the signs because I've indicated here now that upward is going to be the positive direction in this analysis. We can really do that as long as we declare it. So the upward direction is now regarded as positive, the downward is negative. And that means, of course, that our force here is negative 98 newtons, and the force here is negative 98.5 newtons. Okay. Now, the negative 0.025 meters per second squared acceleration was relative to counterclockwise rotation. Okay, now we're not in that context anymore. We're in the context of a free body diagram on each mass. Okay, so in that context, upward is going to be positive, and we know that the 10 kilogram mass is going to accelerate upward. So its acceleration is positive, and our net force then is positive, and that's 0.25 newtons. I got carried away getting rid of my negative sign. Okay, so there's our net force. Here's our tension. Here's our gravitational force. Now we conclude that the tension is 98.25 newtons because it has to be in order for this and this to add up to 0.25 newtons. So, and of course we can write that out. We write it out over here, as we should in any case. Net force is tension plus the gravitational force. Tension is unknown. Gravitational force is negative 98 newtons. The net force we calculate to be 0.25 newtons, so that's equal tension minus 98 newtons, so the tension is 98.25 newtons. Over here, the net force is downward, magnitude 10.05 kilograms times 0.025 newtons, so we get a negative 0.25 newton net force. So there's our negative 0.25 newton net force. Our gravitational vector is going to be longer than our tension vector. The tension is going to be 98.5 newtons. I'm sorry, gravitational force is 98.5 newtons. We get that over here. And I don't know at what point we declare this to be positive, but if we declared it before we drew these pictures, that should be negative, and that should be negative. Okay, so in any case, our tension plus our gravitational force is going to equal our net force. Our tension then minus our 98.5 newton force is going to give us negative 0.25 newtons, meaning then that the tension is going to be 98.25 newtons. And that's the tension that will give this force the necessary acceleration. We know that both of those tensions are the same. We get identical results for the tension, and that's the way it must work out. if this is a light frictionless pulley, then there's nothing to cause a difference in the tension. There's no force being exerted on the string between here and here, so the string is just being stretched, and it's going to pull back with equal forces on both of its ends. So the tension is going to have to be equal. The string has just one tension in this situation, again with a light frictionless pulley. The fact that we got the same value for the tension is both very illustrative. It shows us something important about the system, and it also confirms that we did it right. I will note that there's some minor round-off errors. If you did all this without rounding anything off, these two would come out identical. Okay, this 98.25 and this 98.25 are both obtained by some approximations. And if you don't make those approximations, you come out with like a 98.24 something. And it's maybe worth doing that, but again, within the accuracy of the information and the number of significant figures, and we've been pretty careless with that, these are identical.